Okay, those of you that were in class today got a little sneak peek of this one. This is our last simplifying problem before we turn to verifying. Verifying is just an offshoot of simplifying. So you'll see what that looks like starting tomorrow. And when we look at this problem, okay, we see that we have a plus sign. Well, let's go through the toolbox. Write everything in terms of sine and cosine. Okay, we have a sine, we have a cosine. Could we change cotangent to cosine over sine? Sure, we could. So yeah, that's an option. What about manipulating and substituting Pythagorean identities for squared terms? We don't have any squared terms in this problem yet. Wink, wink. So right now, we're not going to do this. I'm not going to totally cross it out, okay? Because I know from experience that we may have to come back to the toolbox. So factor out common terms in the difference of squares. We know we can factor when there's the separation of terms with a plus sign, but when I look at these terms, they don't have anything in common. So this is a situation where our factoring radar should go off, but we're not going to be factoring in this problem. Okay, so I could put a check mark and say, yeah, I mean, maybe we factor, but upon second look, there's nothing to factor out. So we're not going to take this route. There are no fractions right now, so we're not going to take this route. There are less than 4 terms, so we won't be factoring by grouping. There is no fraction to work with conjugates within, so we're not going to do that. And we're not going to decompose anything because we don't have a fraction right now. So second look, the only thing we can do, the only tool we can use to start is to rewrite cotangent in terms of sine and cosine. Now, I don't believe this has happened yet in any of our examples. Don't get too aggressive with your cross-canceling thoughts because these aren't going to cancel, right? This is really cosine over 1. And we always said when we use one of the tools from the toolbox, we don't automatically go back and find another tool. We got to simplify what we have. So when we look at what we have here, we end up with cosine squared t in the top and sine t on the bottom. Okay, now we have everything in terms of sine and cosine. We come back to the toolbox. There's nothing more to simplify in terms of when we made this substitution, we simplified with that substitution, and now we're back to square one. What do? We come back to the toolbox and we go through this process again. I'm not going to do this because I already turned everything into sine and cosine form. Manipulating and substituting square terms. Yeah, there are square terms here. Factoring out common terms with the difference of squares. There's not going to be any factoring yet again. I can't factor something out of a denominator, with something that's out here that the math doesn't support that. Okay, so we're not going to do that. Find a common denominator and combine fractions. Now, here's where we can go 2 ways. This is a fraction. This is not. But I could make it a fraction by putting a 1 underneath it. Then there would be 2 fractions, and then I could combine them to simplify that. So this is an option. Okay, again, we're not going to factor by grouping because there's not 4 terms. Multiplying a binomial in a fraction. We have a fraction, but it doesn't have a binomial in it. So we're not going to, and we don't want to produce the difference of squares. We already have a squared term. We would want to produce, and I haven't mentioned this really up to this point, we don't want to produce the difference of squares if we have a squared term already. Okay, we're going to look at that squared term, and we're going to pretty much put our focus up here. Okay, decomposing a fraction. I mean, it can't decompose something like this because there's only 1 term. So you have a choice at this point. And let's, you know what? Why not? We've got time. Well, the video might go a little long, but let's take both routes. Let's take the route where we call this a fraction. Okay, so we'll call this we're taking this route. Finding a common denominator and combining fractions right here. We're going to do this in black ink. So here, I'm going to call this sine t over 1. I'm not going to touch this fraction over here, but I am going to simplify this by combining these. And that gets accomplished by getting a common denominator. So I'm multiplying by sine t on the top and bottom here. And if you want, you can think of multiplying this by 1 over 1 because that's how we get that common denominator, right? And we end up with sine squared t over sine t plus cosine squared t over sine t. Now we have our common denominator. We combine these into one fraction. One fraction is simpler than two fractions. I think we can all agree. Now we're here. Don't get trigger happy with canceling. We can't cancel anything here with this plus sign. We're not going, if you look at this and you're like, okay, I'm going to go back to the toolbox now and I'm going to decompose this fraction. Someone out there is thinking that. Someone out there would try to do that. But understand that decomposing a fraction would get you back into this step right here where we have the two separate fractions. So what did you do? You built the fractions together. Don't then go and break them apart again. Now do something with the fraction that you built, if you can, right? And when we look here, and if we do go back to the toolbox, okay, everything in sine and cosine form done. Manipulate and substitute. There's squared terms. What about these squared terms? What's sine squared plus cosine squared? No manipulation necessary, just a substitution here. This is equal to 1. So I put a 1 there in its place. And 1 over sine is equal to cosecant. And we're done. Okay? So that's combining fractions with a common denominator. Let's come back and take the other approach. The other approach was, where were we? Manipulating and substituting, identifying the squared term for cosine squared. Okay, so we have cosine squared t at this point, and we go off into the margin, right? And I have to do this here. I have to say the margin. This shouldn't really fall in line with this proof that we're doing. Go off to the side and figure out what you can do to this Pythagorean identity, right? To isolate cosine squared t. That's what's in this proof. The cosine squared t is what's here. So is this going to be better, worse, helpful? I don't know, but it's something I can do in the toolbox, is I can substitute something else in place of this. So I go into the margin and I try to isolate that thing that I'm trying to replace. And I do that by subtracting this from both sides. Okay, so we end up with 1 minus sine squared t. So this expression can go in place of this expression. So we come back into our proof and we say, okay, I've got sine t plus cosine squared t becomes 1 minus sine squared t over sine t. Now, we have to kind of Men in Black our memory, where I forget what that thing's called. Neuralizer, I think it's a neuralizer, where they erase the people's memory. We have to erase your memory of what we did over here, okay? Because now in this problem, we do want to decompose this fraction. That's in the toolbox. If we decompose this fraction, we have 1 over sine t minus sine squared t over sine t. Okay, you with me? What's going to happen here? Right? Don't put these back together. We just broke it up. But what happens to sine squared t over sine t? Right? Here's how I show this. This is really sine squared and sine squared, or excuse me, sine t on the top. One of those can cancel with one of these down here. I do that by just crossing out the 2 here and then crossing that out. So the new statement says sine t plus 1 over sine t minus sine t. And we have these two terms, which are opposites, leaving me with the same thing that I got over here. Okay, so 2 different approaches. We got to that one point, and then there were 2 different ways we could go. And there's another 2 that we could talk about. If we had, 1,000 days to go through this, we could talk about all different kinds of ways to get this done. You never know if you're doing it right until you just do it. And then you get towards the end, you're like, okay, I think I can do this. I think I can do this. Oh, look at that. And then you're done. That's how these things work. Okay.